Okay, so we've got a video on the discriminant. It might take a little bit of time because there's a few things to explain. Okay, so the discriminant. Okay, so when we have a quadratic equation, they can always be drawn as parabolas. So for instance, x squared minus 4 looks like this because that can be factorized into x plus 2, x minus 2. And so the x-intercepts are minus 2 and plus 2. And that equation there is the same as that equation there. Okay? And the x-intercepts are when y equals 0. Okay, so copy that and come across. Okay, so when you have parabolas, you could have two x-intercepts if they have, two cuts there, or you could have one intercept if it just has one cut, or you could have no intercepts if it doesn't go there, or it could be upside down that way. That could be like that, that could be like that. So you can have two, you can have one, or you can have none. Okay, so copy that and come across. Okay, so x-intercepts, as we drew on the previous page, are the solutions to a parabola when y equals 0. Okay, that's just basic, you should know that. And this is new. So the x-intercepts in books are also called the roots of the equation. Okay, so the roots of the equation are the solutions to the equation. They're the same word, same meaning, different words. Okay, copy and come across. Okay, so when we have quadratic equations that you've been doing, so for instance, we've done these two quite a few times. So x squared plus 5x plus 6 factorizes to x plus 3, x plus 2. So the solutions are minus 3, minus 2. And this is a non-monic, and we've done this, I think, quite a few times. It factorizes 2x plus 1, x plus 3. So the solutions are minus a half and minus 3. Now these sort of numbers, whole numbers or fractions, they're called rational. Okay, because they can be expressed as something over something. So, if you have a number, any number where you can have a numerator and a denominator are called rational solutions. Okay, copy that and come across. Now there might be a quadratic where you end up with x squared equals 3, so x equals plus or minus root 3. You can't square root 3. These are surds, and these are called irrational. Okay, so you've done those before. And another one might be x squared equals minus 3. No number squared can equal a negative number, so we have no solutions, and this is a new word for some of you. They're called unreal. Okay, and when you do high-level maths, you can get solutions to unreal. You can get a solution to an unreal one. Okay, copy and come across. Okay, now this is where we start. In the quadratic formula, there's a b squared minus 4ac, so it's x equals negative b plus or minus square root b squared minus 4ac over 2a. So this part that lives inside the square root sign is called the discriminant, and this can be used to tell us what sort of solutions we will have. And there's a short way of writing discriminant, it's just a triangle. Okay, so it doesn't matter which way, but this part of the quadratic formula is called the discriminants. Okay, copy and come across. Okay, so here's the guts of it. If b squared minus 4ac equals 0, we have one solution and it's going to be rational. If b squared minus 4ac is a negative number, you can't square root a negative number, so there is no solutions. If b squared minus 4ac is a positive number, there are two solutions. If b squared minus 4ac is positive, there are two solutions. If it's a perfect square, like 25 or 16 or 121, you can square root those numbers, and so we have rational solutions. But if b squared minus 4ac is not a perfect square, like if it's 8 or 24 or 111, you can't get a good number when you square root those numbers. They are surds, so they're going to be irrational solutions. Okay, so we've got b squared minus 4ac equals 0, less than 0, or greater than 0. So they're the only three cases you can have. Equals 0 is 1, less than 0 is none, greater than 0 is 2, but then they can be 2 rational or 2 irrational, depending if it's a perfect square or not a perfect square. Copy, come across. Okay, so now we're looking at some examples. So a equals 1, b equals 5, c equals minus 1. So b squared minus 4, so I won't keep writing that out, but b squared is 25, it's 4 times 1 times minus 1. A negative and a negative make a positive. 29. So there are two, I haven't written enough space, two solutions, and they are irrational. Right. B. A equals 1, B equals 4, C equals 4, B squared minus 4AC, 16 minus 16 equals 0. Equals 0, there is one solution, and it's rational. So whenever you have one solution, it's always rational. Okay, A equals 2, B equals minus 3, C equals 8, so B squared minus 4AC equals 9, 4 2s are 8, 8 8s are 64, equals negative 55. So there is no solutions, or they are unreal. Okay, last one, A equals minus 1, B equals minus 5, C equals minus 8. Okay, so B squared is 25, minus 4AC, 25 minus 4 times 8 is minus and minus is a plus, 4 8 is 32, 57. So it's two solutions and they are irrational. Okay. So I didn't have two solutions rational, but you're looking for a perfect square. So if 57 was actually 64, or if 29 had been 25, there'd be two solutions, but they'd be rational. Okay, that's it. Bye.